We talk to our devices every day, setting cooking timers and asking for weather updates. Voice assistants and natural language interfaces quietly mediate our daily interactions. The financial scale of this technology is immense. The natural language processing market is projected to reach nearly $800 billion by 2034, as these systems become mission-critical infrastructure for global enterprise. Yet, there is a paradox in this widespread adoption. Computers cannot actually comprehend human language. At the hardware level, machines only process numerical data, the rigid logic of zeros and ones. This raises a question. How did engineers successfully teach silicon to parse human intent and execute complex workflows? Translating human chaos into machine logic took decades. It required scientists to rewire how computers process information, moving through three distinct eras of discovery. The foundations were laid in the 1950s. Early AI theorists, including Alan Turing, believed the key to human language lay in cracking its formal underlying structure. The methodology of this era was hard coding. Linguists manually wrote thousands of strict grammatical rules and syntax trees, loading them into room-sized mainframe systems to guide how the computer parsed every sentence. This produced early chatbots like Eliza in 1966. Eliza used basic pattern matching to simulate a conversation. It could mirror your words back to you, but it lacked any actual semantic understanding. These rule-based systems eventually reached a limit. Human language is too irregular and context-dependent for rigid coding. If a user used an idiom or slightly broken grammar, the system would fail. By the late 1980s, computer scientists realized that syntax rules were not enough. They abandoned traditional linguistics and turned to pure mathematics to find a better way. In the 1990s, the approach moved from teaching grammar to calculating probability. Instead of rules, researchers fed machines massive data sets from the internet to help them predict which word was most likely to follow another. Word2Vec is an algorithm that converts words into mathematical coordinates, mapping them as vectors in multidimensional space. It calculates the distance between word clusters. Seeing that king relates to man like queen to woman, it learns relationships through geometry. Statistical models had a bottleneck. They read text sequentially, one word at a time. This meant they often failed to maintain context over long paragraphs, forgetting how a sentence started by the time they reached the end. That changed in 2017 with the introduction of the attention mechanism. This allowed models to process entire blocks of text simultaneously, focusing on the most relevant words in a sentence regardless of their position. This breakthrough launched the era of large language models. These systems, built with billions of parameters, achieved a level of fluency in text generation that finally felt human. However, generating language is not the same thing as acting on it. While these models could talk, they still couldn't do work autonomously. By 2026, the landscape has moved past simple text generation. The standard prompt and response cycle is now being replaced by something more capable. We are seeing the rise of Agentic AI. The language model is now a reasoning engine with perception and memory. Crucially, it adds an action layer, autonomously using external APIs, software bridges to other programs, to pull data and run tools to execute plans. Enterprises are now deploying agentic swarms. Instead of one AI, they use hundreds of specialized agents that collaborate on multi-step objectives, checking each other's work and solving problems in real time. The role of the human operator has shifted. We no longer micromanage individual digital tasks. We orchestrate these swarms by setting high-level intent and defining the constraints they must follow. In this new landscape, an organization's success depends on its agentic infrastructure. Automating complex reasoning is the ultimate competitive advantage. The era of passive instruction is over. Human language has officially become the interface for autonomous machine action.